I'm Rakesh Bobba. I'm a research member of the Assured Cloud Computing Project at University of Illinois. In the last 2 years of this project, we focused on two projects in terms of securing cloud computing. The first one is focused on admission control for virtual images running in a cloud infrastructure. The big advantage of using cloud computing is that users have the flexibility to launch their applications contained in a virtual image and run them in the cloud infrastructure, scaling their computational ability as needed. But from infrastructure administrator's perspective, he wants to assure that this software doesn't compromise the assurance level or the security of the infrastructure. So he wants to ensure that this software is trustworthy. So there are different points that the software can, the assurance of the software can be ascertained, and it's either before the software is actually launched on the infrastructure or after it is launched, it can be monitored. So for dynamic assurance that the software is trustworthy, memory introspection techniques have been proposed by others, but we focused on static assurance before the software even gets launched into the infrastructure. This is important for high assurance infrastructures that Air Force would be interested in, so they can keep control of what software gets in and out of their infrastructure. So in the past, people have used mostly malware scanning or virus scanning to ensure that their virtual images are clean, but we argued that that isn't sufficient for high assurance infrastructures, and we designed a whitelist based framework where the virtual image is actually scanned for all the software that it contains, and it's rated based on the level of assurance each of these software packages have inside the infrastructure. So you'll see a demo of that during the review meeting. The second project we focused on in the past was coming up with scalable key management services for cloud infrastructures. So there are different types of clouds. Infrastructure as a service cloud computing is one paradigm. Software as a service cloud computing is one paradigm. And recently, security as a service is gaining popularity. For example, your email servers or spam filtering for your email, such as cloud-hosted email, is one example of a security as a service paradigm. So what we wanted to do in this one is, in many cases, distributed applications need to communicate with each other securely when they're running in the cloud, and we wanted to provide a key management scheme for those. So we focused on designing a group key management scheme that can scale to the level of the applications running in the cloud. But we wanted to do it using existing or well-known software. So what we did is we came up with a group key management service built on top of Zookeeper, which is a well-known, commonly used coordination service in the clouds. And the key thing about this project is, instead of just designing and testing it or assessing it for security afterwards, we used formal methods, specifically MOD and PVESTA, to actually vet the design of the service, and we actually found some race conditions in our design, and we fixed them.